So this video is going to look at solving equations with brackets. That is, how do we apply the distributive law or similar concepts to solving equations that haven't looked like the ones we've done previously. Now, many of you may have seen some of this last year with your teacher, but we'll see how we go from here. Once again, though, our learning goal is using the knowledge of math operations and inverse operations to solve equations. We're just doing it in a slightly different order. So there's two methods we can do these sorts of questions with. One is the distributive law, so we expand our brackets first, as we've done previously. The second is to just consider what happens with brackets normally with our order operations, and then work through them in inverse order and inverse operations. So here's a couple of examples to get us started. They're not really any more challenging than the ones we've done, just a slightly different take to them. So I'll show you the two different methods. One is using the distributive law first, so we can expand these brackets as we have normally, multiply the 7 by each term inside the bracket. So we have 7 times x is 7x, 7 times negative 5 is negative 35. That just gives us a two-step equation that we can solve. So from there, use any of the methods we've used before. Normally you multiply by 7 and take 35. So that's moving forward through the equation. Moving backward, we do the opposite, which is plus 35 and divide by 7. So let's do that now. So we add 35 to both sides. We get 7x equals 63, and then divide by 7 as the inverse of the multiply by 7, giving us x equals 9. Now we can substitute that in to check our answer. And let's do that. So we get 7 times, sorry, that's a 7 times 9 take 5 equals 7 times 4, which equals 28, which is what we've got there. So we are correct. Let's look at this second example. It's got a minus in the middle, but that doesn't change anything. Or the second method, I should say. So this time, using our order operations, normally what we do first is the bracket, according to order operations, and then we multiply by 7. So we take the 5, then multiply by 7. Working backwards, we do the opposite, the inverse. Divide 7, add 5. And there's our solution. So we're going to go through that way. Multiply by 7, divide by 7 first to undo the 7. So we get x take 5 equals 4. And then we add 5 to both sides. The second operation there. Giving us x equals 9. Both solutions are the same, and both give us a valid solution to the answer. Here's our second example, once again with the distributive law. Multiply out first, and we get 6x plus 18. So we undo that by taking the 18 first, giving us 6x equals negative 11, and then divide by 6. So that's a fraction. That's an actually valid answer. It's not one that can be simplified much further than that. All you can do is write it as a mixed number, which we don't tend to do very much when we hit senior. So that's a valid answer. It's much more accurate than a decimal answer. The other way is inverse operations. So once again, just consider that we would do our brackets first normally. So it's plus 3 and then times the 6 after that. Working backwards, divide 6, take 3. So there's our forward operation, there's our reverse operations, or inverse. So if we divide by 6 first, we end up with 7/6. This one's not as easy to do this way. And then we take the 3 away. So convert that to sixths. 1 whole is 6/6, so 3 wholes is 18/6. So we get 7/6, take away 18/6. That should be. Let me just fix that up, which means we have negative 11/6, the same answer as before. So that's how we deal with brackets, inverse operations. It's really no different to what we've done before. You've just got a couple of choices.